Hi, I'm Bob, and I'd like to welcome you into an introduction into propellers. And we have several different type of propellers and all the different parts of the propellers we're going to talk about. What we have on the screen right now is a wooden fixed pitch propeller. And as you can see that it is wooden and it does not change blade angles. The next propeller that we're looking at right now is an aluminum fixed pitch propeller. Obviously it looks different from the wooden, and it's made out of aluminum. It does not change blade angles. As we look at this propeller, this is your steel propeller. These were used during World War II on like DC-3s and big cargo planes, and it is a steel blade. And as you look at it closer, you see that the hub of it's actually rusting. What color is rust? Red. And as you can see, that is rusting on there. We look closer at the blade, and we'll see that there is actually some surface corrosion on that steel propeller. Remember learning that in general? What we're looking at now is the tip of the blade. That's the furthest part from the center of the hub, is what we call the tip of the blade. The other end of the propeller blade is the root, which is closest to the hub. Where we're pointing right now is called the back of the blade. That is the part that's going to be going into the wind as the aircraft is flying. That's called the back of the blade. And strangely enough, the part that we would think is the back of the blade is called the face. The face is usually painted black if the pilot's looking through it so he doesn't get a reflection from the sunlight. And it is the part that the pilot faces. Remember, the pilot faces the face of the blade. What we're looking at now is the trailing edge of the propeller blade, which is the thin edge, the trailing edge. And the leading edge of the propeller blade is the thicker part. That's the part that's going to go through the air first. And remember, propeller blades are an aerodynamic or airfoil, produce lift, which is actually going to make thrust for the aircraft. Some of the positions as blade angles rotate, we can rotate these blades in the hub. And as we're looking at this propeller blade, we can see that the leading edge is pointing into the oncoming wind coming towards us. And that is called the feathered position. We're going to use that when we have engine problems and we need to shut the aircraft down, and that's going to reduce blade and windmilling, something we're going to talk about later. And this position would be low pitch, high RPM, where we're taking a smaller bite of the air. By taking smaller bite, we're going to have less resistance of the wind, and the engine will run at a higher RPM. Low pitch, high RPM. And right here, we have Mike Newman walking into a propeller blade. This is something you do not ever want to do.